The dot product is an operation that takes two vectors and gives an answer in the form of a scalar. The dot product compares how similar the two vectors are directionally. If we have two vectors and the angle between them is acute, then the dot product would be positive. If the vectors are perpendicular to each other, the dot product would equal to 0. If the angle between the vectors are an obtuse angle, the dot product would be negative. So let's say that the two vectors we want to take the dot product of is vector A and vector B. So again, the vector would have three components, an x, y, and a z. So this is going to be the general formula of the dot product. So we read this as a dot b equals ax times bx plus ay times by plus az times bz. So let's say that we wanted to find the cross product of a and b, but instead of given the vectors, we are just given their magnitudes and the angle between them. We can use the following formula: a dot b times the magnitude of a times the magnitude of b times the cosine of theta, in which theta is the angle between vectors a and b. If we are given the vectors a and b, and we wanted to find the angle between them, we can rearrange this formula to get theta equals the inverse cosine of a dot b divided by the product of their magnitudes. So now let's do some examples. So number 1, find the angle between vector a equals 2i minus j minus 5k and vector b equals 3i plus 4j plus k. So this is an ijk notation. If you want, you can put the vectors into component form. So remember, to find the angle, the formula is theta equals the inverse cosine of a dot b over a times b, their magnitudes. Okay, so let's do the numerator first. Let's find a dot b. So first we multiply the x components, which is 2 and 3. We add it with the products of the y component, negative 1 and 4, and add again with the product of the z component, negative 5 and 1. So this is a 6 minus 4 minus 5. This ends up being negative 3. Now we need to find the magnitudes of vectors a and b. So for vector a, we use the equation square root of 2 squared plus negative 1 squared plus negative 5 squared. So in the square root we have a 4 and a 1 and 25. So this should end up being radical 30. And then for the magnitude of b, the square root of 3, 4, and 1 squared. So 3 squared plus 4 squared plus 1 squared. This ends up being 9 plus 16 plus 1. This is going to be radical 26. Now putting it all in the equation, we get theta is equal to the inverse cosine of negative 3 over radical 30 times radical 26. So theta equals 96.17 degrees, or in radians it's 1.678 radians. Alright, so question 2 says, points A, B, and C form a triangle. Find theta. Alright, so theta is the angle at point A, and we can use the vector formula again to find theta. So the formula is to find the angle between two vectors. If we make A our initial point for both vectors, we can make out vectors AB and AC to find theta. So AB is going to equal 3, 1. Since to go to point B from point A, we need to go 3 to the right and 1 up. And AC, to get from point A to point C, we need to go 5 to the right and 3 down. So vector AC is going to equal 5, negative 3. Now that we have identified vectors AB and AC, we can find the angle between them. So again, the formula is theta equals the inverse cosine of vector AB dot vector AC divided by the magnitude of vector AB times the magnitude of vector AC. Alright, now so let's find the magnitudes of vector AB and vector AC. The magnitude of vector AB is the square root of 3 squared plus 1 squared. This is radical 10. The magnitude of vector AC equals the square root of 5 squared plus negative 3 squared. This is radical 34. Vector AB dot vector AC equals, we're going to multiply the x component from AB and the x component from AC. So there's 3 times 5 plus the y component from AB times the y component from AC. 1 times negative 3. So AB dot AC equals 15 minus 3 or 12. We'll get theta equals inverse cosine of 12 over radical 10 times radical 34. So theta equals 49.4 degrees or 0.86 radians. Alright, so vector projection is how much a vector's component is in the direction of another vector. So if we want to find out how much of vector A is in the direction of vector B, we would drop down from where the head of vector A is so that it forms a right angle with vector B. And then starting from the origin, going to where we dropped off, this is known as the projection of vector A onto vector B. And something to note is that it doesn't matter which vector is bigger in magnitude, and the vectors don't have to be parallel to an axis. So I'll show you an example where the magnitude of A is greater than the magnitude of B, and they're both at a diagonal. So we can still find the projection of A onto B by dropping down from the head of A to the point where it would be orthogonal to B. And then again, theta is the angle between both the vectors. So the projection formula is as follows. The projection of vector A onto vector B equals the magnitude of vector A times the cosine of theta times vector B divided by the magnitude of vector B. If you want to know how the formula was derived, I will go ahead and show you right now. So when we dropped from the head of vector A to form a line that's orthogonal to vector B, we formed ourselves a right triangle in the process. So the orange arrow going from the origin to the dashed orange line, this is known as the component of vector A onto vector B. So relating the angle, the magnitude of vector A, and the component of A onto B, we use a trigonometric function. So the magnitude of A would be the hypotenuse of the triangle, and the component of A onto B would be adjacent to the angle theta. So remember, the cosine of theta equals adjacent over hypotenuse. Adjacent to theta is component A onto B, and then the hypotenuse is the magnitude of A. So the component of A onto B equals the magnitude of A times cosine of theta. So that is the length of the vector. For projection, we have the same thing, but this time we multiply it with vector B divided by the magnitude of vector B. So remember, from the last video, we said that a vector divided by the magnitude of itself is a unit vector. And this just determines the direction. The scalar is from the magnitude of A times cosine theta. So the magnitude of A times cosine theta gives the length, and vector B divided by the magnitude of vector B gives the direction. So I'll put this to the side for now. So in the case that we're given two vectors instead of the magnitudes of the vectors and the angle between them, we'll use this equation. The projection of A onto B equals A dot B divided by the magnitude of V times B divided by the magnitude of B. So this part is a scalar, and this is the unit vector. If you want to simplify the equation, we can have A dot B over the magnitude of B squared times B. And everything here is still a scalar, and this is just the vector B. So this next example says find the vector and scalar projections of A equals 5, 3, 1 onto B equals 1, negative 3, negative 3. So first we'll start with the vector projection. So using the formula, the projection of A onto B equals A dot B over the magnitude of B squared times vector B. And then A dot B equals 5 times 1 plus 3 times negative 3 plus 1 times negative 3. And then this is divided by the magnitude of B squared. So the magnitude of B is the square root over the sum of the component squared. But since this is squared, the square and the square root will cancel each other out. So we'll just have the sum of each component of B. This ends up being 1 squared plus negative 3 squared plus negative 3 squared. And then we multiply this with vector B, 1, negative 3, negative 3. This ends up being negative 7 over 19 times 1, negative 3, negative 3. If you want to multiply it in, we can get negative 7 over 19, 21 over 19, and 21 over 19. So in essence, this is just a scalar multiple of B. Now we will find the scalar component. So we use the component formula of A onto B. This is the magnitude of A times cosine of theta, which equals A dot B divided by the magnitude of B. And this equals negative 7 over the square root of 19. This is just the square root of the denominator of the projection. So in physics, work is the change in energy or the displacement of an object due to force. It is given by the equation W equals F dot D. So force and displacement are both vectors, and if we take the dot product of it, we will get a scalar for work. Now, another form of this equation is if we aren't given the vectors and we're instead given the magnitude of them and the angle between them, work equals the magnitude of force times the magnitude of displacement times cosine of theta, with theta being the angle between vectors F and vector D. And we'll use this in example 4. Alright, so for number 4, a force F of 25 newtons is applied to the cart 30 degrees above the horizontal to the right. What is the work done to the cart if it displaces 10 meters to the right from the force? So in this example, the displacement vector is directly to the right, and the force vector is at a diagonal. So a component of the force goes to the right and a component of the force goes up. The total work done to this is just horizontal because none of the displacement vector goes up or down. So we don't need to worry about the vertical of the F either. However, in this case, we're just given the magnitude of the force and the magnitude of the displacement, and we're given the angle between them. So we can just directly plug them into the second equation. So work equals the magnitude of the force times the magnitude of the displacement times the cosine of theta. So the work being done to the cart is 216.5 Newton meters, and a Newton meter is equal to the unit joule. So we can say that work equals 216.5 joules.